Hello friends, in this video I'd like to solve the following problem from the Czech-Slovak match, mathematical match, 1995, problem number 2. We wish to find all pairs of functions f and g going from the set of integers into itself, such that g is injective and f of g of x plus y equals g of f of y plus x for all integers x and y. It's a nice functional equation. Here are my hints. First, change y to g of y and notice that our left-hand side of our equation becomes symmetric with respect to x and y. You should use that and also use the assumed injectivity of g to find f of g of x. Then, once you have f of g of x, you should set y to be 0 in our very first functional equation to find g of x, and then you should be able to find g of x as well. So give this problem a try and I will see you in just a minute. Alright, so here is my solution. As I suggested, let's mark our equation by asterisk, and I will start with setting or change y to g of y in our condition asterisk. What then? Then we have the following. F of g of x plus g of y equals, well, g of f of y, of f of g of y rather, because I have changed y to g of y, plus x. But notice that, maybe let's write this outer occurrence of g in pink. Notice now that this expression is symmetric with respect to x and y. So I can change x and y, and I can write that this is the same as g of f of g of x plus y. I have changed x and y. So this equals that. And I will use now the fact g is injective. Since g is injective, we can get rid of this outer occurrence of our function g, and we can deduce now that f of g of x plus y equals f of g of y plus x. And now let's set something. Let's mark this equation, or not. Let's set now, or maybe let's mark it. Let's mark it square. I will set y to be 0 in our condition square. Then we have the following. F of g of x equals, well, y is 0, so it's x plus f of g of 0. And let's remember it. Let's mark it triangle. And let's keep it in mind. Alright, and now I wish to go back to my very first functional equation and set y equals 0 in our condition asterisk. So set y to be 0 in asterisk, and then we have the following. F of g of x equals, let's go back, g of f of 0 plus x. G of f of 0 plus x. Excellent. But now, remember that we have our condition triangle. F of g of something is variable plus this constant. So, by our condition, which I marked triangle, we have the following. The left-hand side can be replaced with x plus f of g of 0 equals g of x plus f of 0. And now let's shift our index y, our variable x, to change x to x minus f of 0. and we have the following: x minus f of 0 plus f of g of 0 equals, well, g of x. And we can call, because this is just a constant, we can call this number, let's say, c, and now we know that our function g must be affine. So g of x equals x plus c for some constant c, which is obviously an integer, because our function goes from the set of integers into itself. Alright, so now we know the explicit formula for one of our functions, and how can we find f of x? Well, f of x can be found using, once again, our condition triangle. By our condition triangle, using this fact, we can now see that f of x plus c equals x plus f of g of 0. Alright, and now to find f of x, let's shift our variable x, so let's change x to x minus c. Then we have the following: let's call it f of x equals x minus c plus f of g of 0, and this right here is another constant. We can call it b. So f of x equals x plus b for some constant b. We can of course do that because the domain of our function is the set of integers, so if we shift an integer by another integer, we again land in the set of integers. So this is integer. Alright, so now we know that our functions are affine, and finally we have to do verification. We have two conditions to be checked. First of all, g of x, which equals x plus c, is injective. It really is injective. And moreover, let's now write our expression. On the left hand side, we have f of g of x plus y. F of g of x plus y, well, it is f of x plus c plus y, which is x plus c plus y plus b. And on the left hand side, we have g of f of y plus x, if I am not mistaken. Let me check that. G of f of y plus x. G of f of y plus x. It is. So it's g of x plus b, or y plus b, y plus b plus x, and that is y plus b plus x plus c. Exactly the same. So our solutions, summing up, solutions: f of x equals x plus b, g of x equals x plus c, where b and c are arbitrary integers. And that closes our problem. So yes, that's it. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.